could have said that distance is equal to 400 plus 400 plus, all right, my handwriting is getting worse by the moment here. Let's write it smaller. Plus 400 plus 400 plus 400 and plus 400, because it said we did it 5 times, right? Yeah. Or a lot of people will take the shortcut and say 400 times 5. Either way works. And what'd you get for an answer for distance? 2,000. Okay. And what unit did we have on this? Meters. Okay. So that's your distance. Now for displacement. All right. Displacement. Look at the track. Okay. If we start at this point, where do we stop at? At the starting point. So what's our displacement if we start and stop at the same point? 0. 0 meters. Okay. Now for number 2, we go back to the question. Sam walks 10 blocks west and 5 blocks south. What's his distance and displacement? So I do 10 blocks west and 5 blocks south. So I need to look at, is this a right angle? Yes. So what is my distance? Whoops. My distance, I always do what? I add. So I went 15 blocks. For my displacement, I do what? I need to do what for displacement?
A squared.
That's right. It's a triangle. So a squared plus b squared equals c squared. So 5 squared plus 10 squared equals c squared. So I get 5 squared, which is what? 25 plus 100. 25 is a little messed up there. Equals c squared. So 125 equals c squared. Now, is there anybody else like Brianna who looked at it and they were like, I don't know how to do the square root part? All right, because if you do not know how to do that, just ask. We'll be glad to show you. Okay, it's a simple function on the calculator. But if you get to this point on the test or on the quiz and you're like, I don't know how to do it, are we going to show you on the quiz or the test? No. So you want to ask now so we can show you how. Anybody in the room will be glad to show you. All right, so it's the second and the x squared key. And when you do that, that little square root comes up on your calculator. Then you just say 125. And what'd you get when you did that? 11.18. Okay, and blocks is your unit. Everybody okay with how to do that? Okay, because some of you are just sitting here and you're very passive about how you're doing your openings and everything else we're doing. And that's why you're not doing well on the test, okay? You got to be involved. You got to ask questions so you know how to do things. All right, so number 3. Ask you, if I leave LHS and drive 33 miles to Greensboro, and then I return and drive an additional 11 miles home, what is my distance and displacement? Well, for my distance, how far do I actually drive?
77.
I drove 33 to Greensboro. I drove 33 back, and I drove 11. So 33 plus 33 plus 11 is 77 miles. Okay? Displacement, I would say what? I'd say 11, because what's going to happen to these 33 miles? They're going to cancel out because that's like doubling back, and they're going to subtract. So I'm left with 11 miles. Questions about distance or displacement? Because I'm not going to spend any more time on that today. We're going to move on to speed. We okay with that?
Yes.
All right. Now, I need to hand out some paper. So I can find my keys. No, I don't. I got them all on my desk. Scratch that. I haven't put them in the back yet. All right. Let me have somebody who can hand out these. And I'll do the other papers because they have your test grades on it. And there's that value. All right. Now, once you have those, you need to staple them to these, and I'll pass the stapler out. But your test grades are added up on here. Those just have what you got right on the multiple choice. Okay? So the grade that's on that is not right. So when you look at that, it'll be like, how come I ain't get that grade? All right, that grade is only on 1 through 18. You had 12 more free response questions that were on this test that had to be added in. All right? Now, on the first page down at the bottom where it says MC equals, MC stands for multiple choice. That's how many multiple choice questions you missed. Okay? Anything circled on another page is how many response questions you missed on that page. Circles are always what you got wrong on that page. If it says minus something in there, you missed units. So if it says like 2 and minus 1, that would mean you got 2 questions wrong. And you lost points for units. Okay? Now I'm going to start the stapler around up here at the front by Jacob. You know, if it's staple your Scantron, I don't care if you staple it to the front or the back. It doesn't matter to me at this point. As long as it's stapled to the test. That way you have it if you want to do test corrections. Now, questions about anything on the test, I'll be glad to answer. And ask me multiple choice, you'll be asking for response. Everybody here took the test, so I'm going to send the soul out and be glad to answer questions.
Okay, so I got this one right, but I'm still confused on
Okay, so basically, this is the water. And you drop that rock in. And so the water flows into this beaker. So to find the water of the beaker, you just pour it in here and you read that line which you said was water. So that's the way that water. What else? Huh? You're reading the bottom, it's on the 40. See that? That's above the line. Yeah. Yeah, I told you to circle it on the test. Question number, which one are we talking about? 2. 2's answer is supposed to be B, and you marked A. Question number, no, that's just saying that's what you marked. Okay, so if you look here, when you want to know what the right answer is for those of you who, and don't put your tests up, I'm taking those back up, by the way. You cannot keep your test. I get those back. All right? When you look at the bubble sheet, and I'm going to use Raoul's paper to illustrate here. See this piece right here on the right-hand side? Yes. See where it says PRI? PRI is the correct answer. STU is what you marked. And if you look in where it has question mark at the top, and it says like C and X, C means you got it correct, and the X means you got it wrong. Okay? So if you look down that column, and if it has an X in it, it means you got it wrong. If you look under PRI, that's the right answer, and the STU is the student answer. So if I look at Raoul's first answer, he marked A, the correct answer is A, and under the question it has C because he got it correct. Okay? So if he wants to figure out which ones he got wrong, he has to look for the ones that has an X under it. So like number 18 has an X, so he got question 18 wrong. Okay? That's how you would figure out which ones you got wrong on the answer sheet.
That's what I was saying. I was like,
yes. No, the correct answer is B. These are the correct answers. You marked A. Okay? STU is what you marked. The first column is the right answer.
17 is confusing because you got long width and height, something like length.
You remember the opening question from the day before? And we went over the formula for area. Why do you think I went over the formula for area? And I said, why do you think I put this question on the opening? And I said, the formula for area is what? Length times width. And why do you think I put that there? Because people did what? Yes. That's why I did that. Because people do it all the time. I did get it. A lot of people. Y'all, balls and gloves in your bag or away, not in here. If you corrected everything you had missing, the free response and the multiple choice, you can get half your points back. So you're missing 7, so you could round up to 4. If you have a 60, you could get 20 points back. If you have a 90, you can get 5 points back. You can get half back. It's not only for people who failed or got a D. If you have an A, you can get your points back. If you have a B, you can get your points back. It is for one and all. The problem we have is most people just don't take advantage of it. You can do it at lunch. You can do it after school. Y'all are at a distinct advantage over most people because you have third period with me and you have third lunch. So you could stay and do it before you go to lunch, but it is completely your option. I don't hold people hostage. You have a form you have to fill out. It's not hard. Let's see if I have any made. Yep, I still have some left from last year. It looks like this. Basically, you have to explain. So let me borrow somebody's paper who got something wrong. Some of the questions are very easy. All right. I'm going to borrow Jacob's here. He got number 2 wrong. All right. Now, if you miss bubble, you still have to explain. Okay? So in the first column, he's going to write number 2. He's going to write down the answer is, he marked was D. The correct answer is A. And now he has to explain. Okay? Now, the question says a unit for volume is. This is not one that's going to get a lot of explanation because it's not one that you can explain a great deal about. This one is largely one that you should already know and have memorized. Okay? All right? So volume, units are liters and centimeters cubed. Now, you could say volume equals length times width times height to explain that one, but that's really all you can put there. But if we jump to like number, let's say we do 7. Let's say somebody got 7 wrong for a minute. Okay? 7's a math problem. All right, let's say that somebody put down A. So the correct answer is, what's the right answer for that one? B. Which one? It's C. Okay, C. I had no idea. All right, so when you get to that one, we're doing a density problem, right? You'd have to show me density equals mass over volume and plug in your numbers. So what's the mass of number 7? And 7? 7. I picked an easy one. What's the mass? You have to show me the work.
600.
And what's the volume?
150.
There. You have to do that if it's a math problem. You got to show me how to do it right. Okay? The point behind test corrections is to explain how to do it correctly. Now, this is why people get no credit. Okay? This is how you get credit. I come along and I give you points. Now, this is why people get no credit. Number 3, let's just say the answer is B, and you marked A. I bubbled wrong. You wasted your time coming in here. Okay? Number 4, I didn't study. I don't care. Okay? This gets you no points back on your test. This is what gets you points. You have to explain to me how you know the answer. I gave you the answer. It's on the bubble sheet. If it's a free response question and you don't know the right answer, who will help you get the answer? I'll be glad to. I will show you how to get the answer. Okay? If you're not sure if this will get you points, who can you ask? I'll be glad to tell you before you leave. Okay? That's the point of test corrections. The idea is to help you fix what you did wrong. Okay? If you don't want to do the time, it's okay. Test corrections are completely optional. You choose. Okay? It's an opportunity that I provide. Does anybody else have a question on the test before I take them back? All right. If you would be ever so kind, let me have them. If you have not stapled yours, please make sure they're stapled together. Over there, somewhere. I saw it go by.
What's my grade?
Look on Bible School. I do not know.
So what are you doing? Do you pass this?
What's that? Did I get yours? What? All right, did I get everybody's? All right, if you will, find your notes. We're going to need a calculator today, so if you don't have one, get one. We're going to do speed. And we're going to do a short mini lab, probably before we get out of here today, or we're going to be behind schedule. Yeah.
What's this one?
This was what?
No, I did. Look.
All right. All right, well, let's sit in one person. I need to mark absent.
Off and on.
It's sticky. It's not going to change the humidity in the room. All right, I told you we'd talk about this today. All right, and for some of you, we've talked about this already. Okay? A scalar is just a number. And a vector has a number and direction. So we're going to learn to calculate 4 quantities between, best guess, the next test is Thursday of next week. That's my best guess. Best guess. Okay? Because speed, or the motion unit is pretty short. Okay? So, if a scalar is just a number, and a vector has a number with direction, the 4 things we're going to learn to calculate, only one of them is just a number. 3 of them are actually going to be vectors. So thinking about distance and displacement, one of those was a scalar and one of those was a vector. Any idea which one was which?
Yes.
All right, Logan, what do you think? That's correct, okay? Because with distance, we just added the numbers together. Let's change colors there. Okay, we'll try that again. Okay. All right. A scalar is distance and displacement is the vector. And if you think about all of our examples, when we talked about direction with displacement, I would say we went 4 blocks east, we went 5 blocks south. I would say things like we spun in a direction. I had to say something about where we were going. When I talked about distance, it didn't matter because we always added up what we were doing. The direction was irrelevant. Now, we don't need to know any of that. We're not writing it down. Okay? Now, for the purposes of what we're going to do over the next few days, speed is the only one that's going to be a scalar. Okay? Is everybody caught up with me? All right, the other 3 we're going to learn to calculate starting tomorrow will be vectors. They'll have direction. So, today, we're going to talk about speed. Now, speed is the easiest one to do because it has no direction. Now, some of you may remember speed quite possibly from middle school, depending on your experience when you were there. Does anybody remember the 2 things you have to calculate a speed? Think about when you're driving. All right, think of velocity, hold for tomorrow. You got to have what? Nope, that's another one. Velocity and acceleration are going to be vectors. We're going to learn to calculate those. Distance and time. Okay? So speed is basically defined as distance traveled over time. Okay? Now, because we're talking about the distance traveled over time, the formula is really easy. And this is the only formula that is not, did everybody hear me say the word not? Not on that orange card. The reason it is not on the orange card is because it is the same as velocity. Okay? So when we talk about velocity, hopefully late in class tomorrow, when we talk about that formula, I will tell you that it's the same velocity, same formula as velocity. Because the formulas are the same, does the state write both formulas?
No.
No. Okay? They expect you to remember the speed and velocity are the same formula. So they're not going to give you both. Now, speed has no direction. All right? So, if speed has no direction, is it a scalar or is it a vector quantity? That's right. Because it has no direction, it's a scalar quantity. Now, the only way to know that is to memorize it. Now, for those of you who had biology, and you couldn't keep straight the amino acids, the proteins, and all that other stuff, the only way you could was to memorize it. This is sort of one of those things. Okay? Some of you will hear it once, and you've got it. You never have to study. For some of you, you can't. You got to go back and look at it again. Raul, bring that here and put it on my desk, please. Okay? All right, we caught up?
Yes.
Anybody need more time? Yes, that's, you sure? Okay. So, we've got to be able to recognize and draw two kinds of graphs. Okay? The mini lab we're going to do today is going to involve a graph. So, average speed. What does it mean to say average speed, first of all? Hold on. Let me do them in reverse order. You're going to leave a little space there if you already wrote it down in ink. Let's do constant speed. Let's talk about that first. Usually if I do this one first, it's easier to talk average speed. So let me flip-flop. All right, what's it mean to say constant speed?
It's one speed.
Okay, one speed, steady speed. All those answers I heard are correct. Okay, everything else said is right. All right, so a constant speed is a speed that, that's right, does not change, remains the same. That's why I said, let me change my plan here. Because if I do this one first, y'all can usually all tell me the answer. All right? So, it's a speed that does not change or remains the same. Now, when we draw a graph, some of us had issues on this when I handed the graphs back yesterday. All right? Graphs mean nothing. And I do mean nothing if you don't label the what? The lines, okay? If you draw this for me, it's a really nice line. It's a really nice line. Does it tell us anything? Nothing if it's not labeled. You got to label the X and Y axis, okay? So, distance and time have to be labeled. Don't forget that today in your lab. So, distance and time. How are we going to show graphically that speed is constant? How can we draw one? All right, I got two people who just said this. Let's see what we think. Okay, I'm going to draw it up here. A little long. I want you to tell me what you think now that you see it. It was one of the graphs I was going to draw on these two, so you're on the right track with our conversation today. Okay, I want you to think math class. Okay? Is that constant speed?
Yes.
A whole bunch of yeses. Okay, I want you to think math class. All right? What did we label on the y-axis? What is this line doing? It's going straight. Is distance changing?
No.
Did y'all hear what you said? What'd you just tell me? Distance is not changing. You answered that beautifully. That's exactly what you should have said. You got some math skill out there. That's perfect. Okay? Distance is not changing. So what's happening if your distance is not changing? That is beautiful. Y'all are sitting still. This graph right there is y'all right now. What y'all doing? That's exactly right. This graph is a graph of not moving. That's what that graph is that y'all just drew right there. Y'all are not moving. Okay? That's not moving. That's y'all. Distance is not changing when we draw it like this. Okay? Now, I'm going to label this one. Distance and time. We got to change the line some kind of way to be constant speed. How can we draw it to indicate constant speed. Okay, what's this be, Raul? Can you give me some words to be this?
The straight line from the bottom left to the top right.
Okay, that's a great graph. I like it. That is the exact answer I want. Now, could y'all give me some science words to describe that? Okay, I'm thinking of a word that starts with a D myself. Y'all are working way too hard for this word. What's the line look like?
Diagonal.
Yeah, it's diagonal.
I was thinking backwards, like she was sitting here like, this is an easy word.
It's a diagonal line. That's a what kind of line? It's horizontal. Okay? This one's horizontal. That was diagonal. Okay? Now, to compare it with average speed we're getting ready to draw, this one is diagonal and it's also straight. Okay? It's perfectly straight and it's diagonal. That's going to be important in a minute when we go back and draw average speed. Okay? Because average speed is not straight. Okay? Everybody with me on that?
Yes.
Okay. Everybody got what they need off this board? Okay. So if I go back to average now, tell me what average speed means. Okay, so the speed is basically going to do whatever time. It's going to change, okay? So average speed means the speed changes over time. Okay?
Your graphs
Can be look. Let me get some more. Be right back. Let's see how good physical therapy was taken. Hold the bottle and open the top. Okay, I give up. You can't do it.
How do you pass out?
No, the stretch is almost made me pass out. I told her I was going to use swear words if she would stop pressing on my fingers. All right. Yes, I can close it. All right. Just can't open it. All right, so distance and time. So, if we have distance and time. Now, William's fingers did this up and down thing looking like an EKG machine. Does it have to look like an EKG machine? It can. The only thing that it has to do is not be what?
Straight.
Just not be straight. Okay? So, it can go up. It can flat. It can go down. It can go back up. Okay? It does not have to look like what I drew. The key to average speed is it cannot be straight. Okay? It can just have one bend in it. All right? If it just has a simple bend up and over like that, that's average speed. Okay? Because it's not what? It's not straight. Okay? It doesn't have to be an up and down EKG looking machine. It just has to be not straight to be average speed. Okay? Does that make sense? Okay. Now, we need to be able to do some math. Okay? Fourth period is named this class SMATH, by the way. SMATH. They told me we do way too much math, and so they've renamed it SMATH. All right. So, we're going to do easy And then we're going to work towards a little more complicated. The only reason I put this up here is just to talk about the units, because this problem is really easy. You don't need to write this down. All right, what is the speed of a car that travels 300 miles in 3 hours? Now, most of you can have absolutely no difficulty writing this answer down. All right, speed is equal to distance over time. Now, the thing you're going to find about these problems is they work exactly like density. There are 3 variables. You will know 2. You're finding the missing third. All right? I will work these exactly the way I worked the other problems. So, in this question, it asks you to find the what? Speed. So, I'm looking for S equals the question gives you miles. This is why we practice units the whole first part of the week that we were here, so that when we got to these problems, it would be easier to figure out what they gave us. Miles is a distance, right? So miles goes in for distance, and hours is always going to be an easy one to find, is time. All right? Now, when we do this, some of you wanted to cross multiply last week, and we know if S is by itself, do we need to cross multiply? So we just divide. Now, for our units, when we look at these, this was miles, this was hours. Are either of them the same to cancel out? No. So we need to write miles over hours, or some of you are probably familiar with writing MPH, miles per hour. I would take either one, okay? You can write it either way. Typically in a science class, we write it this way, but if you want to write it that way, I would take it either way. Okay? There's no problem with either answer. All right? Any questions about that? Now, if you have one like this, sometimes when I write it this way, some folks get stuck on what I'm asking for. When I say how far does a car travel in 4 hours at 45 miles per hour, what am I asking you to find? Okay? Because I didn't say what distance or what time. I said how far. What does the word far mean in the question? That's right. How far refers to distance. Okay? Now, does anyone need me to stop so they can write the problem down? Because I will if you want me to wait.
Yes.
I will wait. I'll be glad to do that. Because some folks will work faster than others, and I'll be glad to wait for those of you who want to write it down. There will be a couple of them I will ask you to write down, because there will be in practice problems, and some of you will be like, I can't do that without help. All right, so if we're solving for distance, all right, using the same formula, speed equals distance over time. All right, Alexis, what's my time? If you look at that question, what's my time? That's right, okay? So that's usually the one that's the easiest for everybody to find, right? If you know distance is what you're looking for, what does the 45 have to be? That's why I said find the time first. Okay? So, once you have that, how do you solve for distance? Cross multiply. So, 1 times D is D. 45 times 4 is 180. All right? From there, look at your units. I wrote this as MPH in this one because sometimes people have a hard time with that if they see it. Do you have any units that are the same here and here? So the hours cancel out, and we're left with what unit? Miles. Okay? Questions? Any questions? All right. Now, this one I want to do because some of us did this really wrong on the test. Those of you with good math skills did a great job on it. Those of us with lesser math skills struggled. So I want to do this one because some of us are struggling with solving for something in the denominator. And we will all semester long. This is the one that takes some of us the longest to get, and that's okay. We just have to work on it. So, by the end of the semester, y'all will do fabulous on the exam. Those of you who put in more work will do more fabulous than others, but we will all do fabulous. So, when we look at that question, you want me to wait to get it tonight? I will. Okay, I'll wait. You just got to tell me. Yeah, the Football Hall of Fame people this Friday night.
Where you gonna be?
Mr. Beverly wants you to come out and support him. The Hall of Fame folks.
I think Beverly's gonna be in it.
Huh?
I think Beverly's in the whole thing, so.
Yeah, I don't know who the 5 people are. You didn't put that in the email, just that they're doing it at halftime this Friday night. So do you get to play Friday night, Logan? Well, I didn't know since last time we talked. You said that you.
I said on the sideline go back.
Okay, well, but you didn't get suspended though, right?
I said my leg went white behind. It's on the sideline.
Okay, but my point is you didn't get ejected or anything. Okay, that's my question. So you have the possibility of playing. Okay, all right.
Possibility.
Okay, all right. That was my question. All right. So when we look at the question, all right, what are they asking us to find when they say how long? Time. Sometimes people see the word long and they think what? Distance. But generally, when it says how long, they're looking for time. Okay. So when you see the word long, I want you to think time. Okay. So if we're looking for time, we got to have speed and distance. So when you look at the question, what's the distance in the question? The 12 miles. Okay. So if we know that's the 12 miles, what does the speed have to be, Chase? The 3.5. All right. So this is where some of us are still struggling. What do we do to find our time? We need to what, Alizé? All right. You've jumped over all the algebra to tell people that. Okay. So some people don't see that initially. Okay. You've already processed everything to get there. So you have better skills than some others. So we want to take this and cross multiply. So 3.5 times t is 3.5 t. 1 times 12 is 12. Now, how do we get t by itself? Divide by 3.5. And divide by 3.5 over here. So that's how we get t by itself. Now, that's how you made the leap. You did all that in your head. Now, from there, 12 divided by 3.5 is what? 3.42?
Yeah.
Now, when I look at my units, what's going to happen in miles per hour and miles? And we're left with what?
Hours.
All right, questions.
Hours and 42.
Now, the next 2 questions, I recommend everybody writes down. Okay? Because they're very different from the standard plug and chug in S equals D over T. Now, this is an average speed one, and the next one's going to have a table in it. Okay? This is the one that usually everybody says when I give an assignment, I don't know how to do this one. Okay? So I'll give you a moment to write it down. I got it. What do you think we're gonna do this time? Huh? Need more time? I'm sorry, I'm gonna go to the rest of my physical therapy. I'm just bending my fingers. It hurts, but I can stop. Go ahead. What did you think, Sarah? Okay. How are we gonna do that? Any ideas? No? Alright. Add what all together?
All the minutes together and all of them together.
Okay. So Taylor says, William says we got to add all the minutes together and add all the distances together. So what do we do with that rest? Do we do anything with it?
Subtract it.
Do it.
All right, we are going to divide. So we've got to add the miles right here. We got to add the times, and we got to divide. So the question is, do we do anything with the rest? I've heard yes. I've heard no. I've heard subtract.
Yes.
Subtract it from what?
You don't subtract it.
No, Sierra's saying divide like your miles and your minutes, which is correct.
Oh, yeah.
So I'm just asking what we do with that 10 minutes that says rest.
You don't do that, you rest it.
Okay, so we leave it out altogether.
No, you put 0.
Put a 0.
When you add it to the whole minutes,
Why?
you take away from it. It's basically adding on to minutes. It took you to run the.
Well, you would add it on minutes because you're still minutes.
Okay.
Just use one. You add anything.
All right, so they're saying add it. What did you say, David?
Take away from the minutes.
Take it away from the minutes? Okay. So how many of y'all run track or do track?
I'm confused.
I'm not.
No.
Any of y'all run track?
Really? You run track?
Yeah, I used to.
All right, when you ran track and you start the timer for the lap, if you decide to sit down in the middle of the track for a few minutes,
You
does
add
the timer stop going?
No.
So are we adding those 10 minutes or leaving them out?
add it.
We're adding those 10 minutes in. It doesn't matter if we take a break in the middle, okay? So, when you want to find average speed, okay? Average speed is the total distance over the total time. So, we're adding. So, how many miles did this person go? 3 miles, 2 miles, 4 miles. So 3 plus 2 plus 4. All right, for minutes. We have 40 plus 20 plus 10 plus 45. So, what's that on top? 9 over, what we got? 70 plus 45 is what? 115. It's going to be a tiny decimal number. 9 divided 115 is 0.078. Yep, but this is, remember, miles per minute. Okay? So, miles per minute.
You write empty in.
Okay? So what?
You write empty.
You can write MP. Well, you'd have to write miles per, the abbreviation we use for minutes is MIN.
Empty MIN.
Yeah. All right, everybody got it? All right, the last type of sample problem we're going to do before we do the lab. Get off there. All right, write this chart down. We're going to do this one question, and then we're going to do the lab.
How we doing live?
Huh?
How we doing?
In groups too. It's with a ruler. It's not very exciting. The car lab will be tomorrow. We can't squeeze it in today.
Car lab, we're in an actual car. Race it.
No, it has cars that have its pull string. As you pull the car, strings out, and the car goes across the room. It'd be really nice if you would not break them because the cars are 20 years old. So, you know, they're delicate and they really need to survive 3 more years.
Oh, we need go-karts.
No.
Yes, because I'm independently wealthy and I have my own oval out there with carts on them that we're going to go out and get on. I'm not Bill Gates.
And also, I don't think she wants to get in any kind of like.
No.
Right
They
now.
told me I could not wear my brace as long as, you know, I'm in the room and y'all aren't moving around too much. I go out in the courtyard or in the hallways and he puts it back on if I drive. So,
When we get it to this lab.
You could ride.
as long as y'all aren't bombarding me and, you know, roughhousing, I'm all right. I don't think you're going to attack me.
Last year. When we was leaving.
All right, so we got it? All right, so this time I want to find the speed from a certain number of seconds to a certain number of seconds. So our speed formula is distance over time, right? How many times did I give you? What are we going to do if we have 2 times? Bro, you with me? What are we going to do if we have 2 times?
Yeah.
We're going to subtract them. Okay? We're trying to find from 3 to 8. Okay? We're going from 3 seconds to 8 seconds. Okay? So, when you have 2 times, you subtract. Okay? So, down here at the bottom, we're going to have 8 seconds minus 3 seconds. Now, the problem is, I didn't give you the distances, did I? However, I gave you a table. So you have to match the distances to the times. Okay? So, right here, you see the 8 seconds, and you see the 40, right? So, 8 has 40 for a distance. And then 3 has what? 20. So we're going to put 20 there. So what are we going to do with those 2 numbers? When 2 distances, we do what again? You subtract. So 40 minus 20 is what? 8 minus 3 is, so 20 divided by 5 is, now our units come from up here in the chart. What do we have on top? That's meters. Over. Now, last question. Using the same chart. Okay, same chart. Oh, that was Alizé. I was like, what I'm not going. All right. How do we find average speed? Bree, wake up. You're going to need to know this from the lab. How do we find average speed? No. Okay. This is like split times in track, okay? Let's say Bree's running the mile, and she ran it 4 times around the track, right? So, after 10 meters, 2 seconds, she ran 10 meters. In 3 seconds, she'd gone 20 meters. So she'd gone faster. After 5 seconds, she'd gone 30 meters. After 8 seconds, she'd gone 40 meters. And after 10 seconds, she'd gone 50 meters. Okay? It's like split times, right? So this right here is the total time. And this right here is the total distance. Right there at the bottom of the chart. You don't have to add anything. So how far did Bree go when she ran? She ran how far? Her distance is 50 meters. And how long did it take her to do it? 10 seconds. So 50 over 10 is meters over seconds. Okay, you don't have to add. They're split times. So the total distance is at the bottom. The total time is where? At the bottom. Any questions about that? Okay. Now, I need 2 volunteers. Some rulers, make sure they all have centimeters.
I got it.
All right. And then here's the last sheet.
That was something of mine. Everything. Everything.
You won. Then you take the rest of the handout.
Everything.
They worked the other day.
Everything goes inside out of there too. Still haven't seen it all. You? I wrote that bit.
Oh, yeah.
I should have rolled out of that. That's not gonna work.
All right. Everybody got a ruler and a paper? Because I'm going to let you work in groups of 2. Because there are 20 of us. Stick them over there, my desk. I got any extra rulers, or do I give you all 20 of them? All right. All right. Take your front edge of the ruler, okay, right here. And I want you to line it up with right there on the front edge of the hockey puck, okay? Right there at the front edge. Now, you're measuring to the very front edge of this hockey puck, the front edge of this one, to the front edge of this one, this one, this one, and this one, without lifting up the ruler, okay? Now, these are not going to be whole number measurements. Now, at 0, whoops, I just moved this stupid ruler. I'm going to do a couple of them with you. At 0, what does it measure? At 0 seconds, what does it measure? What does it measure right there? It measures 0. So 0 centimeters.
I don't want to make it 15.
Where? All right. At 0.1, what does it measure right there?
2.1.
I'm pointing to it. Point. Okay. Let's see if I can move my hand without moving the ruler. Okay, right here.
Oh, 4.
4.2. You got the idea? Now, did I pick up the ruler as I'm reading along those hockey pucks?
No.
No. So you and your partner are going to read the measurements. Now, once you have the measurements, do not try to answer the questions until you draw this graph. Now, what did I tell you you have to make sure you do on these axes? But I tell you had to make sure you do.
Number.
A, make sure you number them because I'm not numbering them for you. But you need to do what? Label them. Okay? What did we label over here a while ago? Whoops, anybody remember what we put on Y? Distance. What did we put here? I told you that in the directions in case you forgot. Now, if you look at these numbers, you're counting from 0 to roughly 13, 12 point something, so 13. What would be a good number to number? I'm going to shrink this a little bit now. What would be a good number to label this by if you've got to go from 0 to 13? 1. Count by ones. This has got to go from 0 to 0.6. What would be a number to count by from 0 to 0.6? 0.1 would be fine. Okay? So you and a partner can find a spot either in a desk or at a counter to work. You're not in groups of 6 or 8. You're in groups of what? 2. If I see you going around copying people's papers, I'm going to give you zeros. All right, get to work. What's up?
Can you sign yours? It's teacher recommendation. No, I have to sign it. I feel like
That's all I got. Can't have juice, can't open the bottle of water.
But that's if you.
We'll get there. Slowly but surely.
so, Miss Rose.
Yeah.
Miss Rose. Why do we Miss Rose? So you just be looking so serious. That she.
Yeah.
Messed up.
I don't know.
You don't know.
The people who did it yesterday during lunch got it done during lunch. But everyone's going during lunch. You can work on that right now. Stop worrying about the other.
Okay.
Yes. I'm going, Virginia. You got to do the graph. Yeah, because you can't tell me the shape of the graph until you've drawn the graph. Guys, to answer question 1, it says, what's the shape of the graph? You have to have drawn the graph to answer the shape of the graph. I'm not asking for you to tell me that the graph is a square. Okay? You're not telling me it's a square because the graph paper is square. You got to draw the graph first, okay? So make sure you do that. I've been doing one hand for a long time. 2 hands is up. You stop playing over there and do what you're supposed to be doing. Now, be sure you notice the time. This is due to me at 1:20. Put that in the basket. Number your graduate, I will take yours. Guys, you transferring? You're transferring?
Yeah.
It's consistency.
Call it,
Right. Yeah.
I know. Okay.
Yes, ma'am.
Stop it.
Yes, sir. Count by ones.
So this is the side and the bottom is pointing.
Yeah.
So this is for 26 by 21.
Yes. Yep.
For the time the point starting to rain, we can go this and go in the middle.
Like 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. You can stop at 0.6. You don't have anything bigger than 0.6.
Oh.
What?
I know with this one. We know.
No, I got no problem.
What you mean? I don't got nothing. What you got? Let me see that. Oh, the back. No, this part. I got token for. You got all the way. So we got a pot. They answer this question. Tom, 21.
Boy.
He probably did it like that. He did it like that. That's what he did, but he did it like that.
I did.
Let's see.
So this shit's basically straight now.
That first one right there is 1. So 1 point, whatever, has to be 1 point something centimeters.
I guess so much.
G-O-N.
I should use your hand.
Ever did.
I have a question about
This is over time. This is over time. Logan, do not break any of that glass work side. I will lose my, you know what.
It's our job, you gonna punch you.
what is the shape of the bread? What the fuck you mean with the shape? You guys put
Wait,
You should have a straight line then. I don't know.
that's not what you got. It's good. You should try it.
Yeah, my shit look like this. Right, I mean, it's going on. But you count about 10, 9. Oh, but it don't go to 0.6. Because that's the time at the bottom. And these, we doing it regular. Like how to say, 0.1 and 2.1. Oh, my.
You'll be okay. Have a car with something.
You got close? Speaking of grab constant. Yeah, that's diagonal straight, right? That means the constant that remains the same. Yeah. I hate when somebody explains it. Because it is diagonal.
What about?
I'll take it right away.
Would you be saying the same thing?
Make this double vinegar. It's that one marinade that you require a little bit of vinegar. He pulls the shirt up every time. He's got to make.
They say,
Yeah, it's supposed to be very healthy for you. Unfortunately, because my heart burns out. I'm asking what happens to your graph if it had like 0.7 seconds. What happens to the graph? Okay, tell me that. And that one's just a scenario when you're ice skating and you have a graph. What's going to happen to the graph? You can draw the graph, explain it, and you just tell me what's going to happen to the graph. You got to tell me.
It works.
Can I what?
You get 0.01. Because, okay, because I put 0.6 first instead of 0.1. And I got
How do you spell it?
HORIZON. HORIZON. You gave me the spare. You didn't give me the other.
Well, then you can be set/CM.
Flip it. CM is on top because it's distance over. And then S on top.
I remember.
All right. Thank you, my dear. All right.
You said 0.6. How would the graph change? Oh, it's gonna be. What you get? A shot. What you get? Two, 4, 6, 8, 10, 12.
So if you had another.
You're not just playing the
27 seconds.
Okay, so you put this one on my tissue.
So that's over there.
Now we can say how it changed. You gotta explain it to me, which I really do not understand.
Yes, right there on the chair. On the chair.
Chair.
Yes. Right there.
Who's all got?
On my desk. When you guys are done, put the rulers on my desk and your live paper on the chair. That's fine. You keep your rulers.
Keep your ruler.
Make sure you put your calculators in the tub. For example, I see one on that back counter back there. Don't make me chase calculators down when y'all are gone.
If she has to chase that, I'm chasing you.
I got y'all.
What? Number 5, read the question. I'll tell you. I'm not gonna say an answer, but I'm gonna say ask. Read me the question. You only got a certain amount of time to read the question. God. You can't follow simple directions.
Oh,
Hey.
it's